Hello everyone. In this video I will explain AOMDV routing protocol. This protocol is actually a reactive routing protocol used in mobile ad hoc network. So a reactive routing protocol are protocols which actually start discovering for route when it is needed. So we are already having AODV routing protocols. So this is actually a invariant of AODV routing protocol, and here it maintain actually multiple paths during route discovery. So we will see the main difference. So how AODV works: whenever a node wants to send any data to another node, it will start route discovery phase, and this phase is actually started by broadcasting route request packet. So let's say as this node S wants to know where is node D in the network, so it will broadcast a packet, route request packet. So whenever a node receive a route request packet, they actually set a reverse path to the node from where they are receiving the packet. So B will set a reverse path, A also will do same. Now these node also will broadcast it again if they are not having route to the destination. So in such cases, here if you can see, node D actually receiving two route request packet. So in AODV, if a node is receiving multiple copy of same route request packet, only first route request packet will be entertained, and all other packet which are coming after that will be simply dropped. So here we can say D will set a path to S through B. It will not set a reverse path to A. So the thing is that in AODV, if a node is receiving multiple route request query packet for same destination, it will forward or it will broadcast only first packet, and it will set reverse path to the node from where it is receiving first route request packet. All the packet receiving after that route request packet simply dropped. Whereas in EOMDV routing protocol, it allow a node to receive multiple route request packet and allow them to set reverse path. So it might be possible that one node is having multiple path for a another node. So here how things work. So here node D actually receiving two route request packets. So it will set two path. So this node is having actually two options. It can send its data either using this path or using this path. So this is the way AODV is different from EODV routing. Okay, now the thing is that when a node maintain multiple path for a destination, now it might be possible that every path will be having different hop count. So in AOD routing, when these nodes actually share their information, so which hop count will be shared? For example, let's say node D is having two paths for node S. This path is having hop count 2, this path is having hop count 3, and D wants to share this information to another node in a route reply packet or in a okay. So in such cases, one change has to be introduced, and that change is that whenever D wants to tell its neighbors about the distance between S and D, it will opt maximum hop count path. So it will share 3 hop count, not 2. So these are the two components which we are going to discuss in this video. First one is that maintaining multiple loop free path for source or destination, and second one is that maintaining multiple linked disjoint path. So we will see one by one. So what is the first one? How we can maintain loop free path? So now e- in AOMDV routing, we are allowing a node to receive multiple route request packet, and we are asking that node to set a reverse path to the node from where that packet is coming. So if we consider this scenario, node S is sending a route request packet to node A, so A will set a reverse path to S, and A will forward this packet, let's say, to B. Actually it is broadcasting So B will set a reverse path to A. Now this node B also again broadcast it. So when this packet will be broadcasted, A also will hear the same packet again. And what A will do, A also will set a reverse path. So such kind of problem can occur in situation when we allow a node to receive multiple route request packet. So how this can be avoided? This can be avoided if every node will receive route request packet from the path or from the trajectory which not include that node itself. So if we can see here, this route request packet actually passed from A to B and then again A. So A will simply not entertain this packet because this packet is coming from the trajectory which already include this node A. So we will see this thing, how this thing is actually achieved in AOMDV routing. So this is the first thing. Second thing, link disjoint path. The meaning of link disjoint path is that from a source to destination, it might be possible there are multiple paths. So link disjoint path, multiple path which are not having any path common. So here if you can see, if we consider this path, so this is having, we can say this is a 3 hop path, this is another 2 hop path, and this is another 4 hop path. So these three paths are not having any path in common. So this is known as multiple uh, disjoint, link disjoint, sorry. Now and here we have seen actually three paths, one with 3 hop count, one with 2 hop count, and the last one is 4 hop count. Now in case when we are having multiple path, there will be multiple hop count. So which hop count will be shared with neighbors? So that will be the maximum hop count, and this hop count actually known as advertised hop count. So in this scenario we can say advertised hop count between S and D is 4. Okay. Now the thing is that how are we going to uh, maintain this link disjoint path? How we would know that uh, when node set a reverse path or when they update their table, how we would know that they are actually maintaining disjoint paths? So for that purpose, AOMDV routing protocol actually uses one property, and that property is node disjoint path property. This property says that if a route request packet is coming from a different neighbor of a source, let's say this source S is interested to know location of E, so it will broadcast a route request query packet. So this packet will be received by A, C and B, and these neighbor again broadcast those packet. So if a node receiving route request packet coming from different neighbors of source, then those packet actually coming from a node disjoint path. How is that? Let's see. If we look at in this scenario, this S will broadcast packet received by A, C and B, and these three node again rebroadcast it. So when A broadcast its route request packet, that will be received by D, and when C will do that, it also received by D. So A route request packet is going through this path, so D is receiving one route request packet from here to here and one packet from here to here. So node disjoint path, what is that? In node disjoint path, except source and destination, no nodes are in common. So if we consider these two paths as A, D, S, C, D, except S and D, source and destination, no other nodes will be common. Okay. So this property is actually used to achieve node disjoint path. So if we look at the complete scenario, what will happen at E? So A and C will broadcast their packet, and node D will receive two route request packets. Now, when a node receive multiple route request packet, that node actually set reverse path for both or for all of those route request query packet, but it will forward or it will broadcast only first route request packets. So here this node is having two options. It has received two route request query packet. One is coming from neighbor A, one is coming from neighbor C. So it can either broadcast first route request packet coming from A, or it can either forward another packet coming via C. So let's say it is forwarding this one, A1. So D will send a route request query packet to E, and so E will receive two route request packet. One will set this path E to D, D to A to S, and another one E to B, B to S. So in this one, if we can see, after S there is neighbor A, there is neighbor B. So if a route request query packet is coming via unique neighbor of source, those query packet actually set a node disjoint path. So this, in this complete scenario, two node disjoint path will be set, one SBE and one SADE. Now the thing is that if we going to calculate node disjoint path in our network, there will be very few path. So instead, for going for this node disjoint path, we actually used link disjoint path. So how that thing is achieved, in AOMDV routing protocol, destination node actually adopt loser reply policy. Now what is that? Whenever a destination receive multiple copy of route request packet, it will not entertain only the first one. It will send reply to up to k copies, and this k can be set. So here if we consider this scenario, this node S actually broadcast its route request query packet. So here we are denoting it copy 1, this is copy 2. It will be sent to A, it will be sent to C, and it this copy 2 via B to C. So C is receiving here multiple copy of same route request query. So it will receive both copy, it will set reverse path to source S, but it will broadcast only the first query packet. So we are assuming, let's say it received only it received copy 1 first. So C broadcast copy 1 again. So here copy of copy 1, copy of copy 1. So this packet, the first route request packet, will be broadcasted again. So node F will receive two route request query packet. Now what destination will do? Destination will send actually reply up to k copies, and here let's say we are considering it will send reply to two copies of route reply packet. So one copy will be sent via this route and one copy will be sent via this route, because destination is having multiple route, so each copy will be sent to one path. Now here this node is actually receiving two route reply packet, and this node is having actually two options: either it can send data using this path or using this path. So when a intermediate node received multiple route reply packets, and if that node is having multiple path to source, it will send one route reply packet to each path. So it received actually two route reply packet. One route reply packet will be sent through this one, and one route reply packet will be sent through this one, and source will receive two route reply, one which will set this path and another which will set this path. So if we look at this scenario, one path we can say S A C D F, another path S B C E F. So this is not node disjoint path, because node C is common in both paths, but this one is a linked disjoint path. There is no link common between these two paths. So this loser reply policy actually help uh, us to achieve link disjoint path. Now how this link disjoint path thing actually achieved? So we will see that thing with the help of one example. In AOMDV routing, the routing table structure is that this is same as AODV routing protocol. The only difference is that instead of hop count we are using advertised hop count, because it might be possible that there are multiple paths available, and in case of multiple path there will be multiple hop count. So which hop count we will use? So we will use maximum hop count, that is also known as advertised hop count. Sequence number, this is same, this is will specify how fresh the information is. Route list, now instead of next hop which used in AODV routing protocol, here route list is used, and this list is actually stored data in this tuple next hop and what is the hop count for that hop and lifetime. So in route request packet, the only changes from the AODV routing protocol is that instead of hop count, advertised hop count is included, and one more attribute is included, that is first hop. What is that? It will actually specify from which neighbor of source this packet is coming from. So let's take one example, it will clear things. So A wants to know location of node E. So A will prepare a route request packet. So first attribute, this is the source address, so A will put its own address. Second one, this is the source sequence number. So this sequence number, whenever they're going to send another request, this number will be increased, or they are going to send a reply to another node, this sequence number will be increasing. This will be the broadcast ID, or we can say this is the ID for our route request packet. This is the destination address, it means this node A is looking for E. Destination sequence number, this is not known at this time. And hop count, this actually specify, and this is actually advertised hop count, it will specify the distance between node A and the current node. So current node at this time is A itself, so distance is 0, and here first hop. So far this packet is not forwarded to its neighbor, so this field also not known. Now this packet will be broadcasted. So when B receive this packet, it will set a reverse path. And how these node actually do that? So they will create one entry in their routing table. How? Okay, these node will look at the source address. So they will find out that a packet with this source address coming from node A. So definitely that node is available in this side. So they will create an entry that in order to reach node A, send our packet to this node, and this node is A itself. And C also will find out that this packet is coming from this node, and this node is zero distance, zero hop away from the node A. So from C this node will be one hop away. So it will increase this number and put it in the next hop list, that node A is away from node C with one hop count, and for at this time there is only one path is available, so advertised hop count also will be 1, and sequence number it is taken from this packet, and this will be inserted in table. Now B also will do the same thing, it will set a reverse path, it will insert all entries. Now what these node will do, C will insert its own address here. So first hop C will insert its own address and B will insert its own address. So whenever any intermediate node will receive these packets, that node will find out this packet is coming from this neighbor of source, and every node actually maintain a first hop list for every route request packet. So let's say if a intermediate node receiving packet from C and B, so it will create one entry that for ID 1 route request packet, one packet came from C, one packet came from B. So if multiple packets are coming via different hop, first hop, they will be received. Otherwise first packet with let's say if a node receive two route request packet, and if both are coming via this node C, so only first will be entertained, second will be simply discarded. So this actually used to find out whether these route request packet are coming via linked node disjoint path or not. So these packet again rebroadcasted. So now when D will receive this information, D will find out that in order to reach this node, I have to contact B, or I have to forward my packet to B, and B is one hop away from the node A. So the total distance between D and A will be 2. So next hop will be B for destination A, and the total hop count is 2, and advertised hop count will be 2. Sequence number will be taken from the packet. So this is the way they set up their reverse path. And the same for E. Here node E will receive a route request packet. So E will find out in order to send any packet to A, forward those packet to C. C is one hop away from A. So from E the total distance will be 2. So E also will create one entry in its routing table. Now this packet will be sent to node E, and whenever every node sending this packet, they actually increasing this hop count. Why? Because when D is sending this packet, now the hop count is 2. So this hop count is actually specifying distance between current node and node A. So if we can see distance between D and A is 2 hop count, that's why D has included 2. So E is receiving one more route request packet. So E will look at here. So E will find out this packet is actually coming from neighbor B, and previously it has received a packet which is coming via neighbor C. So if route request packet is coming from different neighbor, this will be inserted in routing table. So node E also create one entry for that route request packet. So every node actually maintain a first hop list for every route request packet. So now if we can see, this routing table is actually having two paths for node A. One path having 2 hop distance, another is 3 hop distance. So advertised hop count will be maximum of these two. So advertised hop count is 3. So where this advertised hop count will be used, let's say if in future E receiving any route request packet for node A, so E will send a route reply packet to those node with this hop count. Okay, now it's time to send reply. So node E will create one reply. So this first one is the source, second one destination, this is the sequence number, and this is the hop count between current node and node E. So initially this packet is at node E itself, so distance is 0. These packet will be forwarded to D and C. So D and C will set up a path for E, and D also set up a path for E. So how they will do this? They will create one entry that in order to send any data for destination E, forward that data in this direction to this neighbor, and this is one hop away. So advertised hop count will be 1. Sequence number, this is taken from this packet, and same for node D. D will broadcast this packet, B will receive, B also will create one entry, and here, so here now what will happen when a node receive multiple route advertisement packets. So route advertisement packet actually include route reply packet and route error packet. So when a node receive multiple route advertisement packet, uh, so in this scenario this node first receive this packet. So here it will find out that node E actually 2 hop away via C. Now it will receive another route reply packet with same sequence number. So if a node is receiving same sequence number, it will check whether the new route reply providing a shorter path or not. But via B this path is longer than this path, so this route reply packet will not be entertained. Okay, so node A will be having only one entry in its routing table. So the rule is that whenever a node receive multiple route reply packet with same sequence number, route reply with which provide a shorter path will be entertained. And now there is one more case. If a node is receiving multiple route reply packet, the first route reply packet actually providing shorter path, but the second route reply packet is having higher sequence number. So in that case, every time a node is receiving higher sequence number, only that packet will be entertained. All other packet will be discarded. So first priority is sequence number, entertain always higher sequence number packet. If sequence number are same, then prefer shorter path. So this is the way how AOMDV routing protocol works. Thank you for watching this.